Invite the next speaker, which is Tobias Witt from SAS Institute, where he is an enterprise analyst, I guess, is analytics. You have to correct me if I got your title wrong. So he's going to talk a little bit more about how we then take all this data that's coming from the sensors and how we analyze that when the streams of data are coming really fast. So please, Tobias.
Thank you, Björn. Yes, I work in the Nordic Enterprise Analytics Center of Excellence, whatever that means. So getting that title correct is almost impossible, I think. My name is Tobias Witt, and I work for SAS Institute, as already pointed out. And today I was going to talk a little bit about opportunities in analytics of streaming data. And I was actually, a bit curious about this crowd here, and I talked to Björn beforehand what to expect and what your expectations would be, and clearly this is within the area of big data. And he said, well, it's a mixed crowd. They specialize in a little bit of this, a little bit of that, and you can talk about pretty much whatever you want. Just don't bring up the 3 V's instead. If you do, we're going to have to kick you out of the building. So I won't do that, but I thought it was funny because right after I got off the phone with him, I just checked my LinkedIn account, and there's a lot of discussion on these V's still going on there. And there's some guy here, he says, well, actually there's not 3 V's, there should be 4 V's. You see there's someone commenting on the order of the V's. Is volume really the first one, or should it be another one? Guys talking about, well, there's a 5th V apparently. So not only should you focus on data that is not useless, you should also take care of take care of the garbage in, garbage out principle, I guess, the veracity V. I don't even know what that means. People talking about the size of big data, the shape of big data, and so on. So I'm not going to talk about V's today, but I will say this. I'll focus on the velocity. Oh, that looks pretty bad. The velocity V today. I will talk about predictive analytics and how we deploy that on streaming data, on massive streaming data, with a focus on what our clients are doing. So I won't be getting very technical today. But before I do that, maybe I should just spend a minute or so on SAS Institute. I don't know how many of you in here today thought that, well, an update from the airline industry. Sounds nice. I hate to disappoint you. This is a different SAS. This is this acronym stands for Statistical Analysis Software. Yeah. So it's a company founded in North Carolina in the United States in '76. And we do statistics, obviously. Started out as an application for analyzing this DNA strings in corn, and we've grown from there. So today, I think we're generally considered a market leader in analytics, in advanced analytics, that is. Everything from, foundation stuff like standard deviations and so on, all the way to data mining, text mining, and optimization problems. So this is what I'll be talking today, specifically then for streaming data. So, here we go. This is streaming data. This is very basic stuff, of course, and it looks a bit underwhelming, perhaps. It's 10 sensors on wheels, looks like, measuring pressure or vibrations or temperature or currency or whatever. I'm not quite sure. It's just an illustration. So this is the basic outset, of course. We want to analyze this, and of course 10 sensors is not really much of a challenge. You can do this, using any kind of software. When you start running into problems, it's typically when you get to, maybe 100,000 sensors, and you have a reading from each one about once every second, and you want to react in real time, meaning you want a processing latency, in the microsecond to millisecond range. So that's where our customers start having problems, and that's where sometimes they turn to us, and we work with what we call, or we don't call it, it's called event stream processing. It's a subset of complex event processing, and it just, it's about analyzing and processing streaming events or event streams. So basically, it's quite simple. It's very similar to traditional ETL in a way in data warehousing. You have data coming in from the left, and you have a number of operations you can do on this data as it streams through. Aggregations, joins, filtering, thresholding, correlations, and so on. And what you get on the other side is just, a different stream, probably less data. So, for example, if we want to look at these 10 wheels, and we don't want, the original streaming data because it is kind of pointless to us. Some simple things we could do using event stream processing is, for example, I want to know if I have 6 out of 7 consecutive data points outside of one standard deviation. I want to know that. I want to know if I have 4 out of 5 consecutive data points outside of 2 standard deviations. That's a sigma 2. I want to know if I have 10 consecutive points on the same side of the center line, and I want to know if I have 10 consecutive points either ascending or descending. Everything else you can throw away. So on the other side, you'll get a much smaller data set, of course, and a data set that you can probably use and get some sort of knowledge out of. You were talking about the data information knowledge paradigm. I guess this applies here as well. So this is a very simple scenario. And I guess we're not here to talk about the simple stuff. I promised predictive modeling. So we have to move then from the foundation analytics and into data mining and optimization. And just before I do that, Björn told me you were, it was a very wide array of knowledge in this room. So I don't know how many of you are statisticians or data modelers. Do we have anyone? Well, a few. So maybe I should spend just a minute on explaining, a predictive model, just the basics of a predictive model. So let's pretend for a second that we are, vacuum cleaner salesmen. And typically, we know that we go to an area with 100 households and we knock on 100 doors. We're going to sell 10 vacuum cleaners because we're very good salesmen. We knock on 50 doors, we're going to sell 5 vacuum cleaners, and so on. So what the predictive model tries to do is it tries to tell you what doors to knock first. So the ideal model would look like this. You know you're going to sell 10 vacuum cleaners. You knock on 10 doors. And you're done. You go to the next district and you knock on 10 doors there. Of course, in reality, it doesn't really work like this. You take everything you know from every sales interaction you've had with all the clients you met, and you try to figure out what sort of, what is it that makes them liable to buy from you? Is it that they have a big house, a blue car, 3 kids? Did they buy a vacuum cleaner 3 years ago and the warranty just expired? What is it? And you take everything you know and you try to predict what doors to knock. So in this case, if the red line is our predictive model, we will knock on 10 doors and we will sell maybe 6 or 7 vacuum cleaners. And then, maybe we won't knock on the next 90 doors just to sell 3 cleaners. Maybe we'll just go to a different district and we'll knock on 10 doors there. And then, of course, if you have 100 salespeople and you have 1,000 districts and you have a bunch of products and you have business rules stating that well, you can only knock on a door once every 6 months and other things like that, then you get into this whole area of optimization, which is the next level. But let's just stick with the predictive model for now. Because even though the statistics behind the predictive model are usually fairly complex, the output is quite easy to understand. Björn said you guys wouldn't shy away from a little code, but yes, you can see it's basically just a series of if-then statements. If house is this, if car is that, if children are 3, then likely to buy. This is called a decision tree, this particular model, because usually you tend to display it like this. And it's really hard to read, I can tell, but it doesn't really matter. What this is saying basically that you're trying to understand what drives customer satisfaction in this case. and you can see the most important variable explaining or determining whether a customer is satisfied or not. It's the rating they give to their sales rep. So if you meet a guy from Brazil, you know he gave his sales rep a rating over 52%, then you're pretty certain he's going to be happy. You meet a guy from Japan, way over here, who rated his sales rep poorly and who bought a game or whatever. It's pretty likely he will be very unhappy. So this is the basic idea of a decision model. What you get is a simple set of rules in this case, and by looking at whatever transaction you have and applying these rules, you can determine an outcome to a certain level of certainty. So that's it. So what happens when you deploy this stuff into the streaming data? Well, this is Geneva, and the dark object on top there, that's the Lac Le Mans. So this is Switzerland. And I don't know if anybody wants to guess what the bee swarm is that is sort of floating over Geneva. It's cell phones. So this is just tracking all the cell phone traffic over Geneva. I don't know what they're doing out on the lake. This is probably demo data, so don't worry too much about that. They're not drowning. But this illustrates a point, because communicating with these customers is an issue, and it's an issue one of our clients had, Telefonica. I mean, like all carriers and mobile operators, they operate in a fiercely competitive landscape. It's hard to get new clients because everybody has a cell phone. So you're left with sort of increasing the revenue from the ones you already have. And doing that is this sort of, I mean, you have to use this tried and true, the right offer to the right person at the right time sort of way of working. And it's difficult, you know. You want to point your offers into this bee swarm of people moving around. So let's take a simple scenario that they were looking at, a top-up scenario. So, you know, I use my cell phone. I don't know, listen to a podcast or something, and all by a sudden I reach the limit on my data plan. So the traffic gets throttled and the phone slows down, which is, you know, annoying. Typically then, there are two ways for a telco to respond to this. Either, you know, you send a real-time offer saying, oh, we noticed that you reached the end of your plan, maybe you should get some more data, it will cost you $10 or whatever. The old way, at least, of doing this was pretty stupid, because you didn't really know a lot about the customer. You sent the same offer to everybody. And I bet if you have a Swedish cell phone and you reach the end of your data plan, you receive messages like this, because I think most operators do it in Sweden. The other way, of course, is trying to use analytics. But then, you know, you need to collect your data, you need to run the scoring overnight, and then you will get the offer the day after. And what Telefonica found was that none of these ways were very good. You get a pretty poor take rate either way, similar and poor. So they thought, well, maybe we can apply analytics on the streaming data and get, you know, the best of two worlds. So that's what they did, you know. They detect the event and they use everything they know about the customer, what I was doing, how much time I have until my plan, you know, refills again. Can you hear what I'm saying? Is there a lot of noise? Yeah, okay, good. What have I been doing the last couple of hours or minutes or days, and so on. And they use the predictive algorithm to try and target me with a specific offer that is suitable for me, via SMS or app push. And then, of course, you know, as you iterate through this, you learn and you optimize your model. An example? What do you mean? Well, I think a big one, for example, would be the remaining days until dethrottling. You know, if I'm being dethrottled tomorrow because I paid my money and tomorrow is the new day, I won't be, you know, I don't want to pay at $10. I might pay $1, you know, but I don't want to pay 100 Swedish crowns. If I was doing something really important, I'd be willing to pay more, you know. So those would be some examples, I guess. So the question is, did this work? Well, I guess I wouldn't be standing here telling you about this if it didn't. they increased the take rate about 5 times. So 5 times the the number of accepts to the offer sent out, which translated to a revenue increase of about, I don't know, tens of millions of euros. So this was actually a big deal. And they did a lot of other stuff similar to this, trying to get people to use more data, try to get people to top up more and earlier, and so on. So this is just one example. But it was very successful. And actually, you know, what I think is pretty fascinating about this example is that it wasn't really such a big deal. This is a big analytics customer, and they have, you know, a fairly standard architecture for interacting with their customers. And I think most of telephone operators today have a similar architecture, or they have stuff for this. So what they really did is they just added the real-time component, the event streaming component in the data access layer, and they added some real-time decisioning on the other side. So this wasn't really, you know, a huge thing. It was an 8-week project. All the while, the guys on LinkedIn were discussing the size and the shape and the number of these. You know, Telefonica, which is a pretty old school company, did this in 8 weeks. So I thought that was pretty nifty. Oh. This is Spain. I'll be honest with you, this has nothing to do with the case I'm about to present either, but I thought it was a nice backdrop. This is something we do with the Sensible City Lab. What we're looking at here is credit card transactions. It's actually supposed to visualize every single credit card transaction in Spain over a couple of days. And my point here is that some of these transactions are fraudulent. And it's similar in a way to what Telefonica was doing. I can't give you the name of this client, unfortunately. It's not a Spanish bank, but it is a bank. You know, fraud happens quickly, and it's hard to catch the fraudsters after the fact. So you either react quickly, or you don't react at all, basically. And reacting quickly implies, you know, quick and stupid, or quick and smart, but then you have to analyze the streaming data. So, faced with a similar dilemma in a way, they did the same thing as Telefonica. So, you see here they have the streaming data on the right and some non-streaming data as well. They have the payment engine logs, the PC banking logs. I think this is supposed to be third-party data, not party data. And even though I showed a picture of Spain, and debit card events and so on. And then they have a number of rules. You know, if the PC is infected, if this is a new beneficiary, if there was a recent credit card limit increase, and if the profile is weak, and that profile obviously comes from a secondary scoring algorithm somewhere, then this is a suspect transfer. It should be spit out into the case management system and handled probably manually after that. So once again, you have a huge amount of data on the left. You spit out a small amount of relevant data on the right that you act upon. And just like in the Telefonica case, okay. Oh, Is this better? Is this better? Oh, thanks. And actually, remember those bubbles I showed you in the previous picture of the event stream processing engine? This is actually, I mean, these are the same bubbles. These are the processing steps of the event stream processing engine, and it's also the if-then statements of the analytical model. So this is actually what it could look like. You have an analytical model saying if this, then that, if this, then that, and if this, then that, and then it's a suspect transfer. This is how it can look like when it's implemented on the streaming data. It's a very basic picture, but I hope it gives you an impression at least of how this works. Yeah, good question. This is actually a profiling of the individual client. So it's something done. It's a batch job that runs overnight, and you just assign a score to the profile. So it's done outside of the streaming environment, and then you just get the scoring in, and you use that as a variable in this analysis. So my final example, and I'm curious to see whether this works or not. There's supposed to be a movie playing now. I don't see one. Yeah, so you get the still image instead. This is supposed to be animated and it flows around, but you just have to do that in your heads now. So my last example is from an oil field operator. And they do a lot of analytics as well, and one of the things they do is a very common scenario. It's predictive asset maintenance. So you want to predict equipment failure before it happens, so that you can fix things before they break down, and also so you can fix things in the most optimum way. You don't spend time fixing things that don't need fixing. But what we're looking at here is submersible pumps, which is basically the pumps you deploy on the seafloor about 8,000 feet down to get oil up. The problem is, the whole point with predictive asset maintenance is sort of the maintenance part. You need to be able to get to the pump to fix it, but you can't get to 8,000 feet below the surface of the sea. You can't even get there to look at it, and you can certainly not get there to fix it. So once you deploy these pumps, they're there for the duration of their lifetime, and you can't really get to them. And you're basically running blind. All you have is sensor data. And on top of that, these are really expensive. They cost tens of millions of dollars. And a pump failure is even more expensive, costing you many times that amount of money just in lost revenue. So obviously, you don't want them to break down. Sorry, maybe I should get some water. So similarly, they deploy event stream processing, obviously. And actually what you can see up here is that, well, it's hard to read, but you can see you have the sigma 1, the sigma 2, and the trend. So it's actually very similar to the example I gave you the very first couple of slides with the with the wheels. This is the same thing. So what they're doing here is that they can have a look at in real time at how these pumps are doing and which pumps are performing or acting a bit dodgy. And they can react to that in real time by, for example, decreasing pressure, just pulling back a little bit on the speed of that specific pump. They combine this obviously with more traditional, analytics to try and determine the integrity and the level to which these pumps are compromised. But this is how they look at all the pumps on all their fields and how they get an overview in real time. And you can actually look at YouTube for this if you're interested. You can look for event stream processing and SAS Institute, and you will get a little video clip showing a guy talking and then this animated if you're interested. So that was 3 examples of what we're actually doing and what the very large clients that we're working with are doing. And what I think is kind of interesting is that these are by no means, early adopters or they are not Spotify or King.com or Google. They're Telefonica and, a bank, which is a very traditional company, and this oil well operator. And they have a lot of legacy IT too. They probably have more legacy IT than you can shake a stick at. So the fact that they are starting to do this, that this kind of clients are moving into actually working with streaming data and getting a lot of value out of it, I think is very interesting. And these are the first couple of clients that we've seen. We see a lot of commotion in this area now, and I think we're going to see a lot more going forward. And obviously, you know, with all the things you've been talking about here today, with the Internet of Things and the smart grids and the smart cars and the smart watches and the smart, you know, refrigerators and everything, we're going to see a lot of event stream processing, I think, and I hope. So I think that was all I had to tell you today. You can reach me in a number of ways, even by telephone. So thank you.